Aniline is obtained by passing hydrogen gas in the presence of heated palladium or platinum with benzene, or by heating nitrobenzene with tin and hydrochloric acid. The haloalkane or benzyl halide is heated with the concentrated solution of ammonia in ethanol in a sealed tube at 373 Kelvin. The free amine can also be obtained from the ammonium salt by treatment with a strong base. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today I am going to start session 2 from the chapter Organic Compounds Containing Nitrogen, that is about amines. In the previous session we have discussed about what are amines, structure of amines, classification of amines and nomenclature of amines. Okay, these are the content which we have discussed in the previous session. In today's session we will discuss about preparation of amines, methods of preparation of amines. There are so many methods to prepare. Amine, in that reduction of nitro compounds, ammonolysis of alkyl halides, reduction of nitriles, reduction of amides, GABRIEL synthesis, HOFFMAN'S bromide reaction. These are all important reaction, and also you have to understand how amines will be manufactured or prepared through these methods. First one, reduction of nitro compounds. Aromatic amines are prepared by reduction of the corresponding aromatic nitro compound. Nitro groups can be reduced into amino groups by treating with a reducing agent such as palladium on carbon with hydrogen gas, zinc metal with acid or tin with acid. If we reduce the nitro compounds, amino compounds can be or aromatic amines can be prepared by using reducing agent such as palladium on carbon or tin. Like this reducing agents, if we use, amines will be produced or aromatic amines will be prepared. Example, aniline is obtained by passing hydrogen gas in the presence of heated palladium or platinum with benzene, or by heating nitrobenzene with tin and hydrochloric acid. Okay, if we use nitrobenzene, that nitrobenzene is going to reduced in the presence of hydrogen with palladium. Aniline will be formed with the liberation of water. Okay, or you can use same nitrobenzene reduced with tin and concentrated HCl, or iron with concentrated HCl. Here also aniline will be prepared with the liberation of water. This is how reduction of nitro compounds. By this method the aromatic amines will be prepared. Okay, here reducing agent will be hydrogen with palladium or tin plus concentrated HCl or iron plus concentrated HCl. Next, ammonolysis of alkyl halides. When an alkyl or benzyl halide is allowed to react with an ethanolic solution of ammonia, it undergoes nucleophilic substitution reaction in which the halogen atom is replaced by an amino group. Here nucleophilic substitution reaction will be going on. In that, halogen atom is replaced by amino group. Amino group means NH2. Okay, a chemical reaction in which cleavage of CX bond of a alkyl or aryl halide by reacting with a molecule of ammonia or an amine is called ammonolysis. Once again, a chemical reaction in which cleavage of CX bond of alkyl or aryl halide that by reacting with ammonia will be call it as ammonolysis. The haloalkane or benzyl halide is heated with the concentrated solution of ammonia in ethanol in a sealed tube at 373 Kelvin. The haloalkane or benzyl halide is heated with concentrated ammonia in ethanol at 373 Kelvin. The reaction of ammonia with an alkyl or aryl halide leads to the formation of substituted ammonium salt. This reaction will lead to the formation of substituted ammonium salt. The excess ammonia removes a hydrogen atom from ammonium ion, leaves a primary amine. Okay, the excess ammonia will be removes a hydrogen atom from ammonium salt and forms a primary amine. Okay, the primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines and finally quaternary ammonium salts. We know in the classification primary, secondary, tertiary and quaternary amines are also present. Here what are the primary amines are formed by the ammonia that will be used as nucleophile to the formation of further secondary amines, tertiary amines and quaternary ammonium salt. Okay, see here, when alkyl or aryl halide reacted with concentrated ammonia, it will form primary amine RNH2. That primary amine when reacted with alkyl halide, it further form secondary amine, tertiary amine and quaternary ammonium salt. The free amine can also be obtained from the ammonium salt by treatment with a strong base. A free amine can also be obtained from the ammonium salt by treatment with strong base. This is ammonium salt reacted with strong base, it will form primary amine. Okay, by this method also it may form, or the previous method also by ammonolysis also it may form. Example, chloroethane reacted with HCl or amine, ethanamine will form, and next alkyl with reacted with alkyl halide, N-ethyl ethanamine will form, and next NN-diethyl ethanamine will be formed. If we take another example of benzyl chloride reacted with amine, it will form benzyl amine, and further alkyl halide if we use, that is chloroethane, it will form NN-diethyl phenyl methanamine will form. Next, reduction of nitriles. Okay, nitriles can be reduced by lithium aluminium hydride or by catalytic hydrogenation to primary amines. Here reduction of nitriles means nitriles going to reduce by using reducing agent, that is lithium aluminium hydride. We know that which is a best reducing agent, and or without using this one they can use catalytic hydrogenation process to form primary amines. This is nitrile by catalytic dehydrogenation in the presence of nickel catalyst, or sodium amalgam in ethanol, it may form primary amine. Okay, this is the general reaction. Or example, methane nitrile, in the same dehydrogenation process it will form ethanamine, or ethane nitrile, it may form propyl amine. The next homologous series of amines will be formed by the previous series of nitrile. Okay, next one, reduction of nitriles. In that only, reduction of nitrile by using sodium in alcohol is called Mendeus reaction. This is nitrile by using sodium in alcohol, that method also is called reduction. RCH2NH2 will formed, means it is a primary amine. Okay, here we can take one example, methane nitrile. When reduced with sodium in alcohol, it will form ethanamine. Okay, this is also same nitrile reduction, but here by using sodium in alcohol, not by catalytic dehydrogenation or lithium aluminium hydride. Okay, that kind of reaction we'll call it as Mendeus reaction or reduction. Next, reduction of amides. Amides yield primary amines on reduction by lithium aluminium hydride. Here also they are using the best reducing agent known as lithium aluminium hydride to reduce amide to form primary amine. This is amide. Here also using reducing agent lithium aluminium hydride to form primary amine. If we take example as acetamide, by using lithium aluminium hydride it will form ethyl amine. By amide it will form primary amine. Next, Gabriel synthesis, which is a very important synthesis in the production of amines, and it is also very important for your examination purpose. Gabriel synthesis is an organic chemical reaction in which primary alkyl halides are transformed into primary amines using potassium phthalimide. The potassium phthalimide on treatment with alkyl halides gives N-alkyl phthalimide, which on hydrolysis with strong alkali like NaOH or 20% of hydrochloric acid gives pure primary amine. Okay, phthalimide, this is phthalimide structure. Reacting with potassium hydroxide, it will form potassium phthalimide. Okay, see here, by replacing H, potassium will be added and later that potassium thalamide with the treatment of alkyl halide, it will form N-alkyl thalamide. That N-alkyl thalamide with the treatment of strong base called sodium hydroxide or 20% of hydrochloric acid, it will form sodium phthalate and primary amine. This is salt and this is primary amine. This is very much important reaction. Once again, this is thalamide. When reacted with potassium hydroxide, okay, it will form potassium thalamide. When reacted with alkyl halide, it will form N-alkyl thalamide. That same N-alkyl thalamide when reacted with base called sodium hydroxide or 20% of HCl, it will form sodium phthalate and primary amine. Okay, we can take here example thalamide reacted with potassium hydroxide, potassium thalamide. Here in the place of alkyl halide, they have used chloromethane. N-methyl thalamide will form. That N-methyl thalamide will reacted with sodium hydroxide. That will form sodium phthalate plus methylamine, which is a primary amine. Okay, this is how the primary amine will form through the Gabriel thalamide synthesis. Next, Hoffmann's bromamide reaction. The method for the preparation of primary amines by treatment of an acid amide with bromine in an aqueous or ethanolic solution of sodium hydroxide is called Hoffmann bromamide reaction. The reaction amides on reaction with bromine in the presence of alkalis at about 343 Kelvin gives primary amine. In this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. Okay. Here, amide treated with bromine and sodium hydroxide solution, primary amine will be formed with the liberation of sodium carbonate, sodium bromide and water. We can take one example, ethanamide reacted with bromine and sodium hydroxide. Methanamine will form. Also byproducts of sodium carbonate, sodium bromide and water will be liberated. Here in the aqueous or ethanolic solution of sodium hydroxide will be used and acid amides on reacted with bromine in the presence of alkalis at 343 Kelvin. This is at 343 Kelvin. This reaction will take place and it will form primary amine. In this degradation reaction, migration of alkyl or aryl group takes place from carbonyl group of the amide to the nitrogen group. Okay, this carbonyl group will be migrated to form the primary amine group. That reaction will called Hoffmann's bromamide, means bromine plus amide reaction will be, bromine and amide molecules will take place in this reaction. So Hoffmann's bromamide reaction will be called. Once again I am repeating, Gabriel synthesis and this Hoffmann bromamide reaction are very much important for your examination purpose, and this is about the preparation of amines or organic compounds containing nitrogen synthesis. In the next class, we will discuss about physical properties of amines as well as chemical properties of amines. I hope you have understood completely whatever I have taught in this session. We will meet in the coming session. Till then, thank you.